Now you can share your screen.
Okay, thank you. Do you see my screen?
Yeah.
Can I start?
Yeah, please.
Okay, thank you. Hello, everyone. I am Carolina Silva Araújo. I'm a master's student from Federal University of Bahia in Brazil, and I will present the paper named Digital Twins to Monitor Physical Resources at Construction Sites with Web Applications. So I want to start with the context of the research, and the context is in Industry 4.0. And the Industry 4.0 can support construction companies in reducing complexity and uncertainty, improving the exchange of information and communication between stakeholders, and improving productivity and quality in the construction sites. Construction 4.0 is a term that represents and thinks to adapt Industry 4.0 for the context of civil construction, and we can use advanced technologies to overcome specific sector problems. And all this context is a great opportunity to overcome losses and inefficiencies in terms of processes, information flow, and collaborative work. The evolution of the digital ecosystems based on BIM, the Building Information Modeling, makes possible the creation of digital twins from physical building environments such as the construction sites. These digital twins can monitor physical resources at the construction site and can be incorporated into the construction management to support decision making. But it's important to use the correct tools to collect and storage and manage and visualize the data. So web applications allow the visualization of the three-dimensional digital twins and also the generation of reports and dashboards to show the collected information. I want to talk a little bit about the digital technologies that we are using in this study. We are using BIM, IoT, Internet of Things, and RFID. The context is the digital ecosystems, and they are composed for groups formed by companies and people and products that share digital platforms to benefit each other, creating value and create also innovation. And we are use the concept of digital twins, and this is a dynamic profile that represent the reality. So we have the digital twins and we have the physical twins. And in the digital twins, we can see historical data or relevant data about the reality. So BIM has potential to become digital twins and can provide a great improved spatial context for IoT. And IoT, on the other hand, can provide relevant information concerning physical elements, status, and physical space status to BIM. To operationalize the IoT in the construction site, on site, we can use the RFID, use radio frequency, and RFID is used to identify elements and can support a large number of unique IDs in the same environment. And the main components of RFID systems are the text that we need to put in the elements that we want to track in, the reader to collect data, and also a control software to manage the data. About the physical resources, we are focusing this research in the metallic formworks. And metallic formworks are relevant physical resources in the cast in place concrete wall constructive systems that are very common constructive system here in Brazil. After the removal of the formworks, there is a persistent stage of defect corrections on the wall that causes rework delays and quality issues. So we observed that controlling the integrity and service life of each metallic formworks using technology, we could reduce these defects. Summarizing the objective of this study aims to present a framework and the application of digital twins to monitor physical resources in construction sites and display the information in real time, focusing here on the approach of the technologies involved. And the objects of study are the metallic formworks manipulated in the concrete wall construction system as a About the research methods, we did a literature review and exploratory research to identify gaps in the literature and the relevant studies, and also to observe practical issues. After this, we had the stage of two definitions and two testing, especially a BIM platform and database. And after this, we have the stage of development of the system, the prototype. There is a digital twin. After this, we did an evaluation of the system and the conclusion with the publishing of the results. The first result is this conceptual framework, and here we can see the physical environment, the database, the derived model, the BIM model, and the website hosting of the web applications. So starting here with BIM model, we need to build a modeling. We need to represent the physical resource that we are studying in the model. In my case, the metallic formworks. We need to add the identity data parameters in the virtual model, in the BIM model, in order to make sure that the virtual model is corresponding to the real elements. And export the BIM model to derive the derived model, and we use it for Autodesk. For BIM model, the software has Revit. Inside the Forge, we have 4 APIs that we are using, and the first one is authentication. There is also data management, model derivative, and view for properly to see the results. And this interaction with Firebase, it's a no-relational database from Google. And in the physical environment, we have, of course, the construction site. We need to insert tags, physical tags in each one of the physical resources that we are tracking. And we need a process of tag reading with the RFID tag reader. And we developed 3 functions, 3 applications, models, change of status, dashboard, and work progress, and I will show you in the next slide. For website hosting, we use Whirlpool. So this is the first model that we developed. This is a construction. The first tool is the progress of the work in real time. This application needs to show floor finishes and other construction according to what happened in the real environment. So in an automatic way, we can collect data and see in the first picture, initial phase of the work with the ground, foundation, and after this, the first stage of the construction with a half pavement and the other pavements until the completion of the building, and of course following according to the constructive system. So this model can be implemented in other applications, such as a study related to construction planning, but here it's integrated with the other models. The second model is a dashboard, and it aims to display detailed information about the selected item, showing the data of the real physical resources. So we have a partnership, a construction company, and this kind of information was important to the process of management. So we can see the name of the element, in this case, the metallic formworks, when we select the elements. And the dashboard will open, and you see the RFID number, information of dimensions, weight, height, and also the defects recorded and menace, information about menace of these elements. Just selecting the physical resource. And the last one, a last tool is a visualization of that shows the maintenance status of the complete project. So if in the moment of assemble, the formwork presents a defect, the color will change to red automatically. And if the color doesn't change, it's because it was not presented the defect. And if it presents a defect, but the was a process of maintenance before the assemble, the color will be green. So it's a way to relate this application allows the manager to correlate the quality of the generated concrete wall with the integrity of the formworks in a visual way. About discussion, we evaluated different BIM platforms such as Clario, SketchUp, Shellkit, BIM Serving, Unity, and we decided to use Forge because the good results in terms of data flow and the visualization of the final model to end users. About the databases, we tried SQL databases, but we decided to use Firebase also because the interoperability with BIM and the data flow. We observed consistency of the information sent by the reader. We didn't have losses of information. The received information on the databases was in real time too. The data flow in a general way was working well. The coverage of information for the physical world was okay too. What happens in the physical world really happening in the virtual world too in our systems. And consistent in changing status, real-time status is change. We had a small delay in this case, but the result was okay for our requirements. And ease of data analysis because the information is visual. And we observed the potential to improvement in managerial analysis and decision making by the managers in the construction site. Conclusions. The main results is the digital twins that integrated a derived model, a non-relational database on RFID systems and a web application. And there is a possibility of implementing these systems to different types of physical resources, provide better control from the perspective of using a new technology at a distance in real time. And it was possible to implement the on-site study during pandemic, but the tests performed in the laboratory were sufficient in the evaluation of the technologies based on our pre-established requirements. So this is my reference of this presentation. Thank you for your attention. If you have any doubts, please let me know.
Thank you for your presentation. We have time for questions from the audience. Is there any questions?